Hi guys and welcome. Today I'm gonna teach you how to use the CDQ instruction. So what it does is like convert word to double word, and in a nutshell it will just take the value of AIX, and if it's signed it will give a value to RDX. If it's not signed it will give another value to RDX. In a nutshell that's it. So I have a Python equivalent for this instruction. So CDQ is like you give it a value. So in this case, just EDIX, and we'll check if it's signed, it will give EDX -1. Otherwise, EDX will be 0. That's it. So yeah, if we just run this example code in Python, you can see here that yeah. So if EIX is like in assembly, you can see that the first MSB, the most significant bit, gives if it's negative, like tell us if the value is negative or positive. And in this case, we can see that this value it's in hexadecimal and it's positive. And in this case, EDX will be just 0. And if it's negative in this case, it will be FFF, which is getting -1. So just gonna do a real quick example. Like this is just a stimulation in Python. What we can do now is just try to. I have a real quick example in assembly. In this case, yeah, our example value here is -42 because yeah, it's the insert for the word, yada yada yada. So in this case, we're just loading this value into EIX, and then we're executing CDX, and that's it. This is just exiting. So yeah, let's just debug it real quick. This is already. So yeah, if you want to see how I do this, yeah. So basically, what I'm doing is this is just a real quick way to compile this assembly and extract it. I mean, to compile it and then link it with the debug arguments. I'm using NASM, and I'm creating the ELF64-bit with the debug, and it's outputting into an O file, an object file, and then it's linking it, and yeah. So as you can see here, we have everything related. As you can see here, we have the source code that will be compiled to an object file, and after that it will be an ELF64-bit. So yeah, so let's just debug this application. Yeah, so what we're gonna do is break into the start. So I'm just gonna do breakpoints, meaning it will start and be there. So yeah. Let's see what's the code in this case. Yeah, so let's just print the code. So x10. Then this is just GDB commands to see the source code. This is E to say, yeah, hey, I want to see memory, and it's consider it as an instruction. I'm just gonna take RIP because it's gonna be the instruction pointer. So as you can see, this is the code that we just compiled, and again, so it will move this file. Oh yeah, wait a minute, I need to. So this is just yeah, whatever. It's not Intel. So yeah. So as you can see here, this is not Intel. It's AT&T. So it's what's doing is like it's from left to right. So it's moving this value to EIX, and then it's executing CDQ, and then yeah. So just gonna try to make it. Let's try. So now let's just breakpoint here. Let's just breakpoint here, and then see the instructions, the registers, RDX and RX, yeah, and then step. So yeah, now RX contains this value, which is -42 in hexadecimal, and then we gonna do another step, and then we execute the CDQ. Now we did execute CDQ. RX won't change because RDX won't be changed, rdx, as you can see here. And if we did our homework, we know that this is minus value, so rdx will be -1. Thank you.